Hello viewers, welcome to the course of Natural Language Processing. This is Anuradha Surabhi from KMIT. Working with the natural language processing models involve dealing with the text data. Our neural networks cannot process the text data directly. These models requires the numerical data for processing. Therefore, a numerical vector must be created from the text. This is the concept of text to vector. Today focus is on vectorization, converting the textual data into the numerical vector representation. There are some possible methods are there. Here are certain methods which we can use for converting a text into a vector. Let us look into each one individually. This label encoding and one-hot encoding are something we are well aware of. Now let us to focus on the concept of bag of words. In the discussion of bag of words itself, the concept of one-hot encoding also will be covered. Let's start our discussion with the NLP task of classifying the email messages either as the spam or non-spam mails. Here are the three documents or the mails in front of us, which represents these are the green colors are non-spam mails and this red color is spam mail. The task is classifying the mail into whether it is spam or non-spam. This is the scenario. One of the NLP tasks that we are considering for discussing the concept of text to vectorization. So these are the three documents, document 1, document 2 and the 3 corresponding to each of the mails. Now we will start building up the vocabulary with the unique words that apply to each of these documents. So here is the vocabulary that appears like this. The unique words with the unique words in those three documents, this is the vocabulary constructed. Now with respect to this vocabulary across these three documents, these are the generated vectors. This representation is called bag of word representation. Looking into this vector, first vector for the document play volleyball. Looking at this, play is the word that occurred one time in the document play volleyball, and volleyball is the word that appeared one time in this document. For the rest of all elements of this vocabulary of the length, this vector values will be 0, only for the tokens that are presented in the document. Looking at the third document, if you see, the play had occurred two times in this document. Have a look on this document. Playing helps health, so play. Here it is for our convenience. This sentence was and the document was taken as it easily, but actually during the processing stage, before converting, generating this vector, these words will be the sentence will be processed so that playing will be lemmatized into the term play and this is stop words will be removed. In the stop word removal process, this exclamatory marks will be removed so that the play is the word that occurred two times in the third document. This type of representation is called, it means in this representation consisting of the frequency of the word that from the vocabulary that occurred in the document will be calculated. Such a representation is called bag of word representation. Okay. So suppose here are certain limitations in the bag of word representation. If this vocabulary here itself in the vocabulary consisting of only 10 tokens are the words, it's not a problem. If we imagine a vocabulary with 10,000 words, then we will get this vector, bag of word representation vector of length 10,000 words, 10k. In 10k, for the small sentence or the email like this two word sentence, only two elements will be presented, frequency will be present. For the rest of all the elements in the document, 10k elements, this is zeros will appear. That is the limitation of this bag of word representation. Of course, we have seen this type of sparsity. This is called presenting number of zeros is called a sparsity presentation. The sparsity presentation is even there in the one hot encoding, but The difference between this bag of word representation and one hot encoding is, in one hot, just I'm giving a glance of this one hot encoded representation of this one. In one hot encoded representation, this 10K element vector will be created for each word in the document. Okay, each word in the document, claim free likewise. But in the bag of word representation, this 10K element vector will be for the entire document. That is the difference. Anyhow, the limitation of this bag of word representation is, one such a limitation is sparsity presentation, more number of zeros. Obviously, it would cost to the more memory space. That is the main thing. And the second thing is, we cannot capture the meaningful relationship between any words in this document. In this representation, this cannot be captured. These are the limitations of this bag of word representation. So, and one more important point that we are missing here is, in language models, and in particularly in language, the order of the words is very, very important. And here in this model, we are just taking count of individual words. We are not considering the order. We are just taking the count of individual words. And we are not capturing the meaningful relationship between these words. These are the missings in the bag of word representation. For example, take an example. Looking at this example, Rahul sat on a sofa and ate a samosa. Rahul sat on a samosa and ate a sofa. So here in these two sentences, replacing the word sofa with the samosa has changed the meaning of the entire sentence. If we use the bag of word representation for sentences like this, which creates ambiguity, which which the representation which not prefer the order of the words, it will create an ambiguity. Lot of mess up will be there. So what we did in backup word representation, here it is. We considered individual words. Rahul sat on, like this. Individual words were considered in the bag of word representation. But instead of individual words, if we are able to capture a pair of words just like the sliding windows or moving windows, Rahul sat on a, likewise, you can see here. Instead of individual words, what did in the viewer bag of word representation, we are considering pair of words as a sliding windows. This type of representation is called bigram notation. Bigrams. If we consider three words at a time as a sliding window, then it is called as the trigram notation. Rahul sat on a sofa, like, and so on. This type of representation is called n-gram representation of the sentences of the text. If this n value is equal to 1, that is called the unigram. Unigram is nothing but bag of word representation. Okay. So to do n-gram representation of the model, here is an example of three documents which are pre-processed with the lemmatization and stop word removal. Look at these examples, three documents we have taken. These are the pre-processed words of the tokens that generated from this process. So then we will build BOW mode, I mean to the bag of word representation model or counter vectorizer model, where each unit is a word. Looking at this bag of word representation model, here from these processed tokens of these three documents, the words are the tokens generated are, I mean to say, vocabulary created with the individual word. Thor, eat, pizza, Loki, tall. Loki already is there, and eat is already included, and pizza is also was already included. This is the vocabulary created with considering the unigrams, or we can call it as the bag of word representation. With this, considering across all these documents, document 1, document 2 and document 3. And when these are processed across these, now the vector that has been generated is this one. Presence of from the first document, the eat pizza were presented. Sorry, Thor eat pizza was generated. In the second document, Loki and Tall are presented, and the remaining these elements become zero. Unigram representation. Instead of unigram, if we consider the bigrams in the vocabulary, it will look like this. Thor eat included vocabulary word. Eat pizza and no more words are there. Stop it. Loki tal included and no more words done. Here it is Loki eat included in the vocabulary and eat pizza already included in the vocabulary. So that this is a vocabulary created with the bigrams of this processed text. Thus, the vector representation of all these three documents across these bigrams, vocabulary with bigrams is this one. Looking at these documents, the vectors, we can say very clearly, comparing this document 1 and document 3, there is a matching value at the place eat pizza in document 1 and document 3. It is resembling these two vectors, document 1 and document 2, are close together in a kind of relationship called eating something or eating pizza like this. When you compare document 1 and document 2, there is not at all any matching value, meaning that document 1 and document 2 are totally different. Now, let's think about you can combine this unigram and bigram representations together to represent the given sentence in more meaningful way. Then it looks like this. So here it is in the vocabulary. Both the unigrams are there and also the bigrams are also included in the vocabulary. So that this vector length, so that the length of the vector will become increased with the size of the vocabulary, which includes both the unigrams and bigrams together, whatever all the possible bigrams together. Obviously, vector length should get increased. So in this document, now looking at this representation and comparing the documents together, it is giving more internal representations, more deeper relationship between the documents will be captured with the combining both one gram and bigram representations of the vocabulary words. Right? But what is the problem? What is the limitation with n-gram is again, if this n is increased, as it is increased, however, it is increased the size of the vocabulary when combining both unigrams and bigrams, as the n gram is increasing, as n increases, it increases the dimensionality and increases the sparsity problem again. And one more major limitation with this is out of vocabulary. Suppose these are the models which were built totally. This vocabulary is based on the data which is used for training the model. Based on the training data, the vocabulary will be built. During the test cases, when the model goes through a completely unknown word, a totally new word, which is not existing in the vocabulary, then you will get an error message. Word doesn't existing in the vocabulary. That is the called as out of vocabulary ooh problem. So these are the limitations with this bag of word representation or n-gram representation of the vector set. Okay. This n-grams we can implement using count vectorizer from the sklearn library using the parameter n-gram range. In the coming sessions, exercises will be shared. There you can experience how to implement n-grams. Right. Now, we will see another popular representation of the text to vectors in NLP, that is called TF-IDF. It means term frequency inverse document frequency. Let's discuss about this one right now. Let's see, this is the news article classification problem. Here are the news articles in front of us. This is the article belonging to the company Tesla. This is Apple. This article belonging to the company Apple. So given an article, the task is, this article belongs to extracting the name of the company about which this article was written. It's also a kind of classification problem only. Take this as an example to discuss the concept of TF-IDF vectorization. Okay. If we see the bag of word representation of the model, here is the count of individual words across the vocabulary for the documents or the articles, article 1 to article 4. These are the unique words and so on. We can't say that well. Okay, this entire vocabulary, and these are the bag of word representation. The meaning that appeared 32 times in Article 1, 4 times in Article 2, and 31 times in Article 3. Price appeared 45 times in Article 1, 44 times in Article 3, and 3 times in Article. This is a bag of word representation of these articles across the vocabulary that we have taken from this. Okay. Now, looking at this iPhone and iTunes values of these two articles, iPhone and iTunes values of these two, Article 1 and Article 2, we can say that these two articles are related to the phone company Apple. So that we can extract from this. Looking at these values, these attribute values of these two vectors, these two articles, we can say this is the Apple company articles related to the Apple. Looking at the mask values, this particular column, I mean the keyword, these values, some values are presented here. Looking at these values, presentation of values in this Musk column, we can say this Elon Musk related to the company Tesla. And these two articles 3 and 4 are belonging to the company Tesla. Some classification is to be done. Okay? Yeah. But if you look at the other terms, that price, market, investor, etc. These are the very generic terms that can appear in every article. This iPhone, iTunes, these are the kind of terms related to the phones and phone company. And Elon Musk, Gigafactory, these are the terms, unique terms related to the Tesla company. It's very clear. But coming to these words, dirt, price, market, investor, here are four words I presented here in the vocabulary. There's such a huge number of words could be there. These are the very generic words that appear, that should appear in each and every article. Looking at the values of these words with respect to these two articles, these values are very close to each other and clearly resembling that Article 1 and Article 3 are similar kind of one particular company. But actually, these two are different. Article 1 and Article 3 are of different class companies. Getting the point? Okay. Now, what has happened here is these generic words having much and more frequency than the very specific words which classifies the actual target. Now the question is here is, we have to reduce the influence of these generic words in compared to the more specific words which can classify the documents in a proper way. I'm just repeating. These generic terms should be suppressed. No, these generic terms should be suppressed. And we have to give priority to the more specific terms. Okay? Right. Now let's see how this will be handled. Look at this. Here is the price is the column that appears 45 times in Article 1, 3 times in Article 2, and 44 times in Article 3. Here it is in three documents. It appears out of four documents. It appears three times. Okay. And similarly, if you see this mask has appeared two times. This mask, sorry, appeared in two documents out of four, and gigafactory appeared in only one document. What we want is this. What this is called document frequency of the words. Document frequency of the term or the word. The meaning is number of times that particular word or term presented in all documents is this is called document frequency. If this count is high, we have to lower its influence. That is the task. Because the price is of count, this count is high, we have to lower this in its influence. If the count is low, we have to increase hyper this influence in the document across all the documents. So Musk and Gigafactory are the terms with the low count. So these will be given high priority, and this with this priority will be reduced. For this, some scoring mechanism will be used. This can be done using inverse documentation. This is called IDF of the term T. We will take the log value. What is this IDF is? It's not a simple inversion 1 by. We are taking across the total documents divided by number of documents in which that T is presented. So that the idea value of this will be, and the logarithmic value will be calculated. It's a mathematical computation. You can refer the sources, what is the need of this logarithmic calculation. Thus inverse document of the term could be calculated. This will be the formula that is used to reduce the influence of the words, the terms which are more generic than specific. A combination of this TF and IDF will helps in resolving our issue. Okay. Now look at the IDF terms of these words. Price. This price has occurred in three documents out of four. So the IDF value of price is 4 by 3. It will be 1.13. In the previous frequency count, price is 3. But right now, in the previous slide, frequency count, document frequency of price is 3. That value will reduced with the inverse document formula. So in that case, now it becomes 1.33. The words with the low frequency, gigafactory and mask, these values, inverse document frequency got increased. So that the words mask and gigafactory, which are very specific, which represents the specific company and the classification variable, has given priority or the high score compared to the more generic terms like price. This had happened because of this inverse document frequency calculation. Okay. Now TF-IDF is simply the multiplication of term frequency and inverse document frequency together is the value of TF-IDF. This is how, what is the TF-IDF representation or the vectorization of these documents across this one. You can now, it is very clear that the mask, looking at the mask value, 0.99 is given, sorry, mask is given high priority and high score with 0.99 that appeared in these two documents compared with all other documents. The meaning is these two documents are close together, and thus zero point 0.9 and zero point 0.9 of these two iPhone and zero point 0.8 and zero point 0.8 of iTunes representing article 1 and article 2 are close together, and these zero point 0.9 and these zero values represent Article 1 to 2 are too different from Article 3 and 4. Thus, the similarity of the sentences vectors will be calculated so that the classification will become easy for the neural network model. This is TF-IDF representation.